Hello students, now in this short video we'll see one problem how to sketch the Bode plot. So a given problem is given, a transfer function is given. For this Bode plot is asked to be sketched, and additional data that is given in the problem is find the value of k when the gain crossover frequency is 5 radian per second. So in this problem, if you observe carefully, how many terms are there? There are 3 terms. First one is derivative factor, second 2 and 3 terms are first order factors in the denominators. So the first step is we need to get sinusoidal transfer function, that is obtained by substituting s is equal to j omega. Now in this problem the value of k is to be determined. As the value of k is unknown, initially let us assume the value of k is equal to 1 and then we'll find the value of k. So what are the 2 steps carried in this? Put s is equal to j omega and let k is equal to 1 value is assumed. So now to draw the magnitude plot, that is the first part in Bode plot, first of all we need to find the corner frequencies. The formula for corner frequencies for first order factors in the denominator is 1 by 1 plus st. Put s is equal to j omega. The value of corner frequency is 1 by t. Now this is of the form 1 by 1 plus j.2 omega. So for this corner frequency is 1 by t, nothing but 1 by 0.2. For the second one, the corner frequency is 1 by 0.02. The values that are obtained are 5 and 50 radian per second. So after getting the corner frequencies, we are going to prepare a table consisting of 4 terms. The first one is the term, second column is corner frequency, third one is slope, the next one is change in slope. Remember the units for corner frequency are radian per second and for the slope are dB per decade. So how to write the first term is, because the value of k is 1, so the first term will be derivative factor. If all the terms are given, the order to write is first term will be k, second term will be integral factor, third term will be derivative factor, but here we have only derivative factor. Okay, that's why we have taken j omega whole square. For this there will be no corner frequency, because corner frequencies are only for first order factors as well as quadratic factors. So a derivative factor has a slope of plus 20. But here why did you write plus 40? The reason is it is of j omega whole square. If it is only j omega, the slope is plus 20. As it is j omega whole square, the slope is plus 40. And coming to the next, how to write these 2 terms. The order to write these 2 terms is in the increasing order of corner frequency. That means whatever is the lowest corner frequency, that is written first, and the highest corner frequency is written in the next one. For first order factors in the denominators, the slopes are minus 20 and minus 20. So what we have done, we have written the term, corner frequency and the slope. What are the slopes? First term it is plus 40, second and third terms are minus 20, because for first order factors in the denominator the slope is minus 20. And coming to the last column, the change in slope. In the name itself we have the answer, change in slope, how the slope is changing. So what is the first value of slope? First value of slope is 40. Now what has it changed to? 40 has changed to minus 20. Just write down what are the slopes, that's all. First write down 40. Now the new slope is minus 20. So how much is the change? 20 is the change. Now coming to the third, next change in slope. Now whatever is the new change in slope, that is 20. For this term, the slope is minus 20. 20 right here. Write the old slope. So 20 minus 20, the change in slope is 0. How much is the change in slope is noted. This is how we'll complete a table. After completing the table, we are going to choose two frequencies. We'll choose two frequencies, omega L and omega H. I'm repeating, we'll choose two frequencies, omega L and omega H, where omega L is less than omega C1 and omega H is greater than omega C2. What do you mean by C1 and C2? C1 is the lowest corner frequency, C2 is the highest corner frequency. Here C1 value is 5 for our problem and C2 value is 50. So any values can be chosen, but the condition is omega L must be less than 5, omega H must be greater than 50. I'll repeat, choose a arbitrary frequency which is less than the lowest corner frequency represented by omega L, and choose a frequency omega H which is greater than the highest corner frequency. So now in our problem, let us assume omega L is 0.5 and omega H is 100. 0.5 is less than 50, less than 5, and 100 is greater than 50. Remember, any values can be chosen, but it is convenient if you take in terms of multiples of 10. Okay, and now A is representing the magnitude in decibels. A represents the magnitude in decibels. So now we need to calculate the magnitudes at all the frequencies. So important thing is, what is the first term? J omega whole square. For this first term, we need to calculate magnitude for two frequencies. We need to calculate magnitude for two frequencies. What are the two frequencies? Means omega L comma omega C1. For the first term, magnitude is to be calculated for two frequencies, omega L and omega C1, using the formula 20 log of the magnitude. So here just observe, go through the step. Omega equal to omega L. A is equal to 20 log of the term. What is the term? J omega whole square. That is substituted. And mod J square is nothing but -1, but as it is mod, we'll take directly positive value, 20 log omega square. What is the value of omega L? 0.5. That is substituted. You are going to get -12. I said for two frequencies. What is next frequency? Omega C1. So the same term is the same, but what is the change? The value of the frequency changes. So after calculating, it is 28 dB. So what are these steps? For the first term, we'll calculate for two frequencies, omega L and omega C1. Omega L is the low frequency which is assumed to be less than the lowest corner frequency. And now next one is omega C2. Omega C2 value in our problem is 50. So the formula, this is the formula for finding magnitude at omega C2. The formula is slope from C1 to C2, omega C1 to omega C2 into log C2 by C1, into log C2 by C1 plus the magnitude at C1. You need to learn this formula, okay, or else I'll tell you a shortcut. What is that means? Change in slope at C1, change in slope at C1 into log C2 by C1 plus the magnitude at C1. Change in slope at C1 into log omega C2 by omega C1 plus the magnitude at C1. So here all the values are substituted. At C1, what is the change in slope? 20. 20 into log C2 by C1 plus the magnitude at C1 is 28. The value is calculated. Okay, and next, the formula for finding the magnitude at omega H is the same. The value is change in slope at C2. Change in slope at C2 or slope from C2 to omega h, which is nothing but change in slope at C2. Okay, change in slope at C2 into log omega h by omega C2 plus the previous gain. Previous gain is nothing but omega equal to omega C2. Whatever is the gain that is obtained, that is added. So for omega C2, what is the change in slope? The change in slope is 0 into log omega h by omega C2 plus the previous gain. Okay, so using these formulas we have calculated 4 magnitudes. In shortcut, you quickly tell me. For omega L and omega C1, the first term magnitude is calculated. For C2 and H, C2 and H are nothing but they are representing omega C2 and omega H. Okay, for these two we are calculating magnitudes using the formula change in slope at C1 into log C2 by C1 plus the gain at C1. Same, next formula is at omega equal to omega H, change in slope at omega C2 into log omega H by omega C2 plus gain at omega C. Now we have calculated all the magnitudes for different frequencies. Now in a semi-log graph sheet, on y-axis magnitude is taken, the value of A in decibels is taken, on x-axis omega is taken. Now for 0.5 the magnitude is minus 12. All these points are marked and all the points are joined by scale. This will give magnitude plot for k is equal to 1. This will give the magnitude plot for k is equal to 1. And now how to get the phase plot? In order to get the phase plot, the procedure is we need to get the expression for phi. So here in our transfer function, what is the first term? J omega whole square, which is nothing but derivative factor. For derivative factor, simply J omega, angle is 90 degrees. J omega whole square, the angle is 180 degrees. For derivative factor, phase angle is 90 degrees. J omega whole square, the angle will be 180 degrees. As the two terms are in the denominator, we are going to write tan inverse 0.2 omega by 1, tan inverse B by A. A is equal to 1, B is equal to 0.2 omega. Same 1 by 1 plus J 0.02 omega is also in the denominator. So the third term will be tan inverse 0.02 omega by 1. Now what we'll do means we'll prepare a table like this. This table is for convenience. Okay, for different values of omega, individually we'll calculate the terms and then calculate the total angle and then calculate the total angle. This will give the phase values. So now here in our problem, I'll show you the original semi graph sheet. Before that, okay, so now check this figure. This is magnitude in decibels because we have positive values and negative values. I have drawn on the y-axis, and now here on the x-axis, this is a decade scale semi-log graph sheet. The x-axis is to be taken in terms of 10. Okay, so if it is 0.1, other thick line will be 1, next one is 10, 100, next one will be 1000, and so on. First of all, we'll draw the magnitude plot. So when 0.5 is the frequency, corresponding to 0.5, what value we have got? The value is minus 12. Next, corresponding to 5, what is the value we have got? The value we have got is 28. Corresponding to 50, the value is 48. Corresponding to 100 also, the value is 48. We have marked all the points A, B, C, D, and these are all joined with the scale, which is nothing but the magnitude plot with k is equal to 1. Magnitude plot with k is equal to 1. What are the changes in the slope? 40, 20 and 0. These are the changes in slopes that have been marked. Okay, so the value of scale is 1 unit on y-axis, it is equal to 10 dB. 1 unit on y-axis, it is 10 dB. Now in the same figure, on the right side, you choose the scale for angle. Choose the scale for angle. Any values can be chosen depending upon the calculated values corresponding to the frequency. Mark all the angles obtained in the table. Join all the points by a smooth curve, that is called as phase plot. That is called as phase plot. Okay, and now the last problem, there is one more step. Calculate the value of K. How to calculate the value of the K means, given gain crossover frequency is given as 5 radian per second. So for this 5 radian per second, if you observe, for 5 radian per second from the graph we have got 28 dB. 28 dB. So magnitude at the gain crossover frequency must be 0, but here it is not 0, it is equal to 28. So when 28 becomes equal to 0, when minus 28 is added. So to get the value of K, the magnitude 20 log K is equated to minus 28, because when minus 28 is added, then only we are going to get the value of 0. So from this, the value of K is 0.0398. So here, for this new value of K, how to calculate all the values means, check this table for magnitude plot values for K equal to 1. How to get for the new value of K? Just for all the old values add minus 28. For all the values add minus 28, we get the new value. So in the same graph sheet, now plot the new values of K. So this is the magnitude plot with K 0.0398. This is obtained using 20 log K is equal to minus 28. Why are we equating it to minus 28? Because according to the graph, at gain crossover frequency 5 radian per second, the value is 28 dB, which must be equal to 0. 28 becomes 0 when minus 28 is added to it. So this figure shows the Bode plot for the given problem. Any problem given for the Bode plot, this is the general procedure. Thank you very much all of